This is a video on differentiation techniques. I had a prep session last Saturday where we went over 24 problems on differentiation techniques, and these problems were actually problems from real AP tests, and these problems are all non-calculated problems, meaning that on average you're going to be allocated 2 minutes for each of these problems. However, in my explanations here, as I go over these problems, I'm going to take a little more than that at least to make explanations clear. And then I'm just going to, instead of reviewing these techniques in advance, we're going to kind of review these techniques as we go. The biggest technique we need to use in differentiation is called the power rule. And if you don't understand use the power rule by now, if you're at least halfway through your calculus course, you're already failing. You've dropped out. In this case, problem 1, if f of x equals x to the 3/2 power, then f prime of 4 equals, and what we do is we take this, we're going to rewrite this as f prime of x, and what we do is we take this power here using the power rule and multiply that by 2/3, and we have x, and we have, I said 2/3, 3/2. We take this 3/2, subtract 1, we get x to the 1/2 power, which is the same thing as square root of x. So we have f prime of 4 is equal to 3 times square root of 4 over 2. Well, square root of 4 is 2, which cancels 2, and so we have 3. So there's our answer. Next problem, 2. If x to the 3rd power plus 3xy plus 2y cubed equals 17, and in terms of x and y, dy dx equals, what we're going to do is do what we call an implicit differentiation, and we're going to take this x cubed, and the implicit differentiation of that is going to be 3x squared. And that's going to be times dx dx, which is 1. And then we have plus 3x times the derivative of y, which is going to be, instead of dy dx, I'm just going to call it d prime, plus 3y, and that's going to be a dx dx, so that's what it's going to look like, plus we have 6y squared, and on the right side we have the derivative of 17, which is 0. And then any terms without, and I did forget something here, it's going to be 6y squared y prime equals 0. There we go. Any terms without y prime, we're going to shift over the right side by subtracting them. So on the left side we have 3x y prime plus 6y squared y prime is equal to, we take this to have negative 3x squared, and we're going to have minus 3y. And we're going to divide everything here by 3. And so that cancels, that cancels, that cancels. This becomes 2 here. So rewriting and factoring out the y prime, we have y prime times quantity x plus 2y squared is equal to negative x squared minus y. And then if we divide by quantity x plus 2y squared, we have cancellation here on the left, and so y prime is equal to negative x squared minus y over quantity x plus 2y squared. Now, do we see any such answer here? No, we don't, but we should know it's an answer choice A. If we factor out this negative sign, we put the negative sign out front, we're going to have x squared plus y over x plus 2y squared And so A is going to be our correct answer for problem 2. Next problem, 3. An equation of the line tangent to the graph of y equals 2x plus 3 over 3x minus 2 at the point 1, 5 is. Well, for this we have the quotient rule. What we're going to do is we're going to take the high function of quotient of two functions. We have 2x plus 3, and the derivative of the high is 2. Low is equal to 3x minus 2, and the derivative of the low, which we'll call d low, is equal to 3. And so y prime is equal to the low, and our low is 3x minus 2 times the derivative of the high, which is 2, minus high, and high is going to be here quantity 2x plus 3, and times the derivative of the low, which is 3, and all over low squared, which is quantity 3x minus 2 squared. And just kind of simplifying now, we're going to have in the numerator, we're going to have 2 times 3x, which is 6x, minus 2 times 2, which is 4, minus 3 times 2x, which is 6x, and we're going to have minus 3 times negative 3, which is 9, and then we have in the numerator same thing, 3x minus 2 squared, and we have cancellation on the top, 6x minus 6x cancel, and so we have left y prime equals negative 13 over quantity 3x minus 2 squared, and if we take y prime for an input value of 1, we have negative 13 over negative 3 times 2 is 3 minus 2 is 1, so we have negative 13, and so our point slope form is y minus y1 equals m times quantity x minus x1, point slope form, and so we have y minus 5 equals negative 13, and we have times quantity x minus 1. So that's going to simplify on the right side to negative 13x plus 13, and on the left side we have y minus 5. And then if we switch, if we add 5 and add 13x to both sides of the equation, we have y plus 13x equals 18, which is going to be answer choice B. Again, a lot of explanation. You would have been able to do this a lot faster without the explanation. Okay, this one should be one of the easiest ones here. If y equals tangent x minus cotangent x, then dy dx equals, what we have is this is going to be a trigonometric function, and if we write out tan secant and negative cotangent cosecant, we find the derivative of something. It's just we cross out, if we write them out this way, what we're trying to take the derivative of. So if we're taking the derivative of tangent, we just cross out the tangent, and what do we have left? Secant. If we're trying to take the derivative of cotangent, or in this case cotangent, we cross out the cotangent, we have negative cosecant squared. And so what that's going to leave us with is dy dx is going to be equal to secant squared x, and we're going to have negative which is positive cosecant squared x. So our correct answer to that is E. Next problem, 5. If f of x equals quantity x minus 1 squared sine x, then f prime of 0 equals question mark. And so for this, if we're taking the derivative of the product of two functions, which we'll call u times v, that's going to be equal to u v prime plus vu prime. And so what we're going to do for that is kind of a organizing technique. It's to write this box. This box here is going to be separated into 4 cells. And we're going to put this first function here, which is going to be quantity x minus 1 squared, and the derivative of that function is going to be 2 times quantity x minus 1. And next, the other factor of this product is sine x, and the derivative of sine x is cosine x. And so what we do is we take the product of these two things here, kind of go diagonal, plus the product of these two things. And to do that, we're going to have f prime of x is equal to quantity x minus 1 squared times cosine x, plus we have 2 times quantity x minus 1 times sine x. And then if we go ahead and put f prime of 0, we're going to be left with x is 0, so we have negative 1 squared times cosine of 0. Well, cosine of 0 is going to be 1 plus 2 times, we have 0 minus 1, well, that's going to be negative 1 times the sine x, which is 0. Well, anything times 0 is 0, so what we're left with is negative 1 squared times 1, so f prime of 0 is equal to 1. So our correct answer to this will be D. Next problem, 6. There we go, there. Okay, for what values of x does function fx equals quantity x minus 2 times quantity x minus 3 squared have a local maximum? Well, again, it's going to be, we're going to use that product rule organizer like we had in that problem 5. Here we go, we take this box here, and we're going to have quantity x minus 2, and the derivative of quantity x minus 2 is 1. And then we're going to have quantity x minus 3 squared, and the derivative of quantity x minus 3 squared is 2 times x minus 3. And so, like we did the last one, we have the product of these two things, diagonal, plus the product of these two things. I'm now insert, okay? So what that's going to be is f prime of x is equal to quantity x minus 2 times 2 quantity x minus 3 plus we have 1 times quantity x minus 3 squared. And what we're going to do is take our common factor of these two terms, which is going to be quantity x minus 3, and what we have left over from here after factoring out quantity x minus 3 is this, 2 times quantity x minus 2, and from this quantity x minus 3 squared, the factor we have left is simply x minus 3. And then just simplifying here in this right term, we're going to still have quantity x minus 3 times, we're going to have 2x plus x, which is going to be 3x, and then we're going to have negative 4 minus 3, which could be minus 7. So if we set this equal to 0, our critical numbers are going to be x equals 3, and we set 3x minus 7 equals 0, we're going to have x equals 7 over 3. So those are our critical numbers. If we go ahead and make out a number line and put our critical numbers here of 7/3, which is going to be, what, 2 1/3 and 3, and we put f prime on top and f down below, and we plug in the numbers here. If we plug in like 0 for x, we're going to get negative 3 times negative 7, which is going to be positive, so the function is increasing up to x equals 7/3. And because we have this 0 with a multiplicity of 1, we're decreasing after 7/3 like this, and then after 3, we're increasing again. So our relative maximum, or our local maximum, is going to be right here at 7/3. So for this one, 7/3 is our correct answer. Next problem, 7. The slope of the line normal to the graph of y equals 2 ln natural logarithm of secant x at x equals pi over 4 is. And for this, we need to know the differential technique of natural logarithms. So we have d dx of the natural logarithm of a function which we'll call v. That's going to be equal to the derivative of v over the original function. So the derivative over the original. So in this case, y prime is going to be equal to 2, and we have the derivative of secant x. Well, if we write out tangent secant, if you remember that from a couple problems ago, we're taking the derivative of secant, which we cross out, we're going to have tangent secant. So we're going to have 2 tangent x secant x, that's the derivative of the function, over the original, which is secant x. And secant x over secant x will cancel each other, like this, and we have left 2 tangent x. Well, we're going to have y prime of pi over 4 and we're going to have equals 2 of tangent of pi over 4. Well, if you look at if you remember unit circle, okay, where is pi over 4? Pi over 4 is right here, the diagonal. So you have your sine is square root of 2 over 2. I mean, your cosine is square root of 2 over 2. And your sine is also square root of 2 over 2. And tangent is sine over cosine, which is going to be equal to 1. So we're going to have 2 times, our answer to this is going to be 2 times 1, which equals 2. So that is our answer choice D. Except, we have to remember, don't we? That would be if we had a tangent line, but remember the normal. Now, this would be m of t, but m sub n is going to be equal to the negative reciprocal of 2, which is going to be negative 1/2. Now they tell me that in the current AP test, they're not going to ask you about normal lines, only tangent lines. But be careful about that. I don't know how well you can trust the College Board. Okay, 8. At what values of x does the graph of y equals 1 over x squared minus 1 over x cubed have a point of inflection? Well, what we have here is we're going to do a rewrite of y equals x to the negative 2 power minus x to the negative 3 power. Your y prime for this is going to be negative 2 x to the negative 3 power, and we're going to have negative 3 times negative sign here, so we're going to have positive 3 x to the negative 4 power. And y double prime is going to be equal to negative 3 times negative 2, which is 6 x to the negative 4 power. And we're going to have negative 4 times 3, which is going to be minus 12 x to the negative 5 power. And if we set this equal to 0, okay, we're going to have negative this. We're going to have 12x to the negative 5th. Well, let me just rewrite that. We're going to have 12 over x to the 5th equals 6 over x to the 4th. And if we just turn these things upside down, we're going to have x to the 5th over 12 equals x to the 4th over 6. And if we multiply, cross multiply here by 6, we're going to have x to the 5th equals 2x to the 4th. And if we set this equal to 0, we're going to have x to the 5th minus 2x to the 4th is equal to 0. And our common factor in this is going to be quantity x to the 4th, and we're going to have x to the 4th times quantity x minus 2 is equal to 0. And so we cannot have a point of inflection at 0 for a couple reasons. One is that we have a multiplicity of an even number multiplicity, so that's not going to change the signs. And also, the function is not defined at x equals 0. So therefore, our critical number here is going to be 2. So we're going to have a point of inflection at x equals 2. Next problem, 9. If f of x equals quantity x squared minus 2x minus 1 to the 2/3, then f prime of 0 equals, well, f prime of x is going to be equal to, we're going to take this power rule, 2/3 times, we have x squared minus 2x minus 1, and 2/3 minus 1 is negative 1/3, and we're going to have also times the derivative using the chain rule on the inside, so that's going to be 2x minus 2. So this is going to be f prime of x is going to be equal to 2 times quantity 2x minus 2 over 3 times the cube root of x squared minus 2x minus 1. And then if we take f prime of 0, we're going to get, if this x is 0 here, we're going to have 2 times negative 2, which in the numerator is negative 4, over 3 times, well, if we set what's inside this radical equal to 0, we're going to end up with cube root of negative 1. Well, cube root of negative 1 is negative 1. So we're going to have negative 4 over negative 3, which equals 4/3. And so our correct answer is A. Next problem, 10. A function f is given by f of x equals x cubed plus 12x minus 24 is question mark, these answer choices. So we're going to take f prime of this. We're going to get 3x squared plus 12. And factoring out, we're going to get f prime is equal to, when we factor out a 3, we have 3 times quantity x squared plus 4. And so dividing by 3, and setting equal to 0, we have 0 equals x squared plus 4. Well, what we have, is there a solution for this? No, there is not. There's no value of x. We can't put any value in for x to make this actually a solution. So, in fact, this is always going to be positive. No matter what real number we put in place of x, we're going to have. So we're going to have no solution. And also x is going to have to be greater than or equal to, let's see, 4, greater than or equal to, well, 2, or less than or equal to, because we have to have less than or equal to -2, right? But in any case, this thing is always going to be positive, so we're going to be increasing for all x. So C is our correct answer here. Next, 11. If f of x equals e to the power of 3 ln x squared, then f prime of x equals. Now for this one, it really helps us a lot to understand our properties of logarithms. So we're going to rewrite this as e to the power of, we can take this 3 ln of x squared, and we're going to have ln, we take x squared and raise that to the power of 3. So we've taken this 3 here and moved it over here as a power using properties of logarithms. So what we have is f of x equals e to the power of ln x to the 6th power. What's going to happen is that e and ln, we have the natural exponent, base e, to the power of the logarithm. And so what we have here is f of x equals x to the 6th power. And so f prime of x is going to be equal to what? 6x to the 5th power. So our answer choice is E. Again, properties of logarithms would really help you out a lot with this one. Next, 12. If f prime of x equals 2x minus cosine x, which of the following could be f of x? There are different ways of doing this. You can take the derivative, the second derivative of each of these answer choices until you find your starting point. But I'm going to go ahead and find use the antiderivative for this. And for that, we're going to say that f prime of x is equal to the antiderivative of f double prime of x dx. Okay, so in this case, we say f prime of x is equal to, we're going to take the integral of 2x, which is going to be x, let's see, it's going to be 2x squared divided by 2, and the integral of negative cosine x, well, the snow cone Santa Claus. So if you integrate, you go the opposite direction. So what that's going to be is, if we take the integral of negative cosine x, we're going to get negative sine x. So we're going to have minus sine x. And then we have f of x is going to be equal to the integral of f prime of x dx. And I forgot here this plus c, the constant integration. So here we're going to have f of x is going to be the integral of this x squared, which is going to be x cubed over 3. And then the integral of negative sine x is cosine x. So we're going to have plus cosine x plus our constant integrations, which we didn't find out, c x plus, we'll call this next one c sub 2. So the only one that this could be is answer choice A. So that's problem 12 using antiderivatives. Problem 13, if f of x equals the natural logarithm of quantity x squared plus 3 minus e to the power of negative 4x, f prime of 0 is, what that is, that's the whole ddx of ln of a function is going to be the derivative of the function over the original. So f prime of x is going to be equal to the derivative of x squared, which is 2x, and we're going to have the derivative of negative e to the negative 4x. Well, that's going to be, we're going to have negative e to the negative 4x times negative 4. And that's going to be over the original, which is going to be x squared plus 3 minus e to the negative 4x. And this negative 4 and this negative cancel each other. So what we have is, we're just going to go and put in f prime of 0 is equal to, in the numerator, 2 times 0 is 0, and then we're going to have plus e to the 0, well, we're going to have 4, because we have 4 out front. E to the 0 is 1, and in the denominator we're going to have 0 squared plus 3, and so we're going to have the 3 here minus, we're going to have minus e to the 0, which is 1. So we're going to get 4 over 2 equals 2. So our correct answer for 13 is C. Next, 14. If y equals x cubed cosine 3x, then dy dx equals, again, as we've done in these product rule problems earlier, just draw out a box like this. So we're going to have x cubed here, and then the derivative of x cubed is going to be 3x squared times, we have cosine 3x, and our derivative of cosine 3x is going to be negative 3. And where do we get negative 3 from? Well, we have that 3 because of the derivative of the inside using chain rule, sine x. And for that, we're going to have dy dx, which I'm going to call y prime, is equal to x cubed. Now, let me do it the other direction first. Y prime is equal to 3x squared cosine x, cosine 3x, excuse me, minus x cubed times, we'll put the 3 out front, 3x cubed sine x. And we're going to have our common factor here is going to be, it's going to be 3x squared. So we're going to have cosine 3x. We're going to have minus x sine x. And that's x sine, I said x, it should be 3x. Again, you'll be able to do these a lot more efficiently than I, having to explain all this as I go. And our answer choice is going to be E for this one. Next, 15. Let f be the function defined by fx equals 2x to the fourth plus 3x minus 4, which is the following is equation line tangent to the graph of x, the point where x equals -2. Well, we need a point and a slope for that. So our point is going to consist of our x-coordinate of x equals -2 and our y-coordinate, which we don't yet know. So we take f prime of -2, not f prime, f of -2 is equal to 2 times -2 to the fourth power minus 3 times -2 minus 4. And that's going to be equal to 3 times 16, which is 32, minus 6 minus 4 minus 10. So we have 22. So we have 22 right here. So that's our point. Next, we're going to take f prime of x is equal to 4 times 2 is going to be 8 x to the third power plus 3. And if we plug in -2, f prime -2, we're going to have 8 times -2 to the third power plus 3. Well, -2 to the third power is -8, so we're going to have -64 plus 3, which equals -61. And so that's going to be m sub t, slope for a tangent line. So using our point slope form, we're going to have y minus 22 is equal to, our slope is going to be -61. And we're going to have times quantity x plus 2. And on the right side, that's going to be equal to -61 x minus 122. And if we add 22 to both sides of this equation, we're going to get y equals -61x plus, excuse me, I said plus, it should be y equals -61x minus 100, which will be our answer choice C. Next problem, which is going to be 16, values of f prime, g, and g prime at selected values of h. Well, I haven't gone over this, but this is going to be a composition. If we have h prime of f of g of x, f of g of x, that's going to be equal to f prime of g of x times g prime of x. And so g of 2 is going to be equal to 2, g of 2 is equal to 4. And then we're going to have f prime of g of 2 is going to be equal to f prime of 4, which is going to be equal to 2. And then finally, g prime of 2, we go to g prime of 2, we get 3. So in this case, we have h prime of x equals f prime of g of x, which is going to be 2, and g prime of 2, which is 3. So we have 2 times 3, which equals 6. So our correct answer for this one is B. Next, 17. We have if f of x equals sine of point x to the negative x, then f prime of x equals, well, f prime of x is going to be equal to the cosine, the derivative of sine is cosine, so we have cosine of e to the negative x times the derivative of e to the negative x, which is going to be simply e to the negative x power times, again, the derivative of this negative x, which is going to be times negative 1. So we're going to get negative the cosine e to the negative x times e to the negative x. And I think that's going to be looking like answer choice E. Yes, it is. Next, 18. Equation of the lines, the graph of y equals x plus cosine x at the point 0, 1 is, well, we have a point already. We need to find the slope. So y prime is going to be equal to the derivative of x, which is 1, plus the derivative of cosine x, which is going to be negative sine x. And then if we plug in 0, y prime of 0 is going to be 1 minus sine of 0. Well, sine of 0 is going to be 0, so we're going to be 1. So if we take y minus y1 equals 1 times x minus 0, we're going to get y minus 1 equals x. So y equals x plus 1. Our correct answer to this is going to be B. Next, 19. If f and g are twice differentiable and h of x equals f of g of x, then h prime of x equals what? Or h double prime of x equals, well, that's what it is. So similar to the problem we did a couple times ago, h prime of x is going to be equal to f of, or f prime of g of x times g prime of x. And next, to take the second derivative, we're going to go and do this thing we've been doing here for a long time. Several of these problems, I couldn't count how many we've done it for. Okay, product rule. We're going to have f, the first item in the factor in that product is going to be f of g of x. And what's going to be the first derivative of f prime of g of x? Well, it's going to be f double prime of g of x times the derivative of the inside, which is going to be g prime of x. And then we have on the bottom, we have g prime of x. And what's going to be our first derivative of this one here? We're going to have g double prime of x. So for this one here, if we crisscross, we're going to have h double prime of x is equal to f prime of g of x times g double prime of x plus f double prime of x, or f double prime of g of x, g prime of x times g prime of x, which is going to simplify to f prime of g of x, g double prime of x, plus f double prime of g of x and g prime of x. We have g prime of x times g prime of x squared. So what that's going to do is simplify out to our answer choice. I think that's what this one is. F double prime, G, is kind of in the reverse order here. But yes, that's going to be answer choice A. Next, 20. If fx equals x times quantity square root of 2x minus 3, then f prime of x equals, okay guys, same thing we've worked out before in several of these problems. We're going to have x, and what is the derivative of x? 1. And then we're going to have the square root of quantity 2x minus 3. Well, to find the derivative of that, d dx of 22x minus 3 to the 1/2 power, we're going to have 1/2, and we're going to have 22x minus 3 to the negative 1/2 power times the derivative of the inside, which is 2. Well, the 2 over 2 are going to cancel each other, and so what we're left with in radical form is going to be 1 over the square root of 22x minus 3. So we have 1 over the square root of 22x minus 3. Not tremendously legible. We'll just keep on going here. So we have as f prime of x is equal to x over the square root of quantity 2x minus 3 plus we have the square root of quantity 2x minus 3. Now if you look at our answer choices here, A through E, we have not a we don't have two terms. We need to have a common denominator. Well, this kind of stumped me. So we're going to get our common denominator of this square root of 22x minus 3. So I'm going to write this right term as a fraction of over 1. And if we kind of cross multiply here, we're going to have 1 times x. So we have x plus, we're going to have quantity, square root of quantity 2x minus 3 times the square root of quantity 2x minus 3. So we're going to have 2x minus 3 in the numerator over the square root of quantity 2x minus 3. Well, we have x plus 3x, x plus 2x is 3x minus 3. We're going to end up with answer choice A. This one stumped me for a bit, but you can see that it is workable. Okay, 21. d dx of cosine squared x to the third power is going to be the same as d dx. The squared notation here can be confusing for people, and so what I'm going to do is rewrite this thing as cosine in parentheses, x to the third power, and then place the squared outside of here. So when we take the derivative of this, we're going to have 2, using the power rule, times cosine of x to the third power times the derivative of the inside here, which is going to be negative sine. We're going to have x to the third power times the derivative of this inside, which is going to be 3x squared. So for this, we're going to get 6x squared, actually negative, because we have this negative sign out here. That's going to be a times negative 6x squared times cosine x cubed times sine x cubed. And that's going to give us answer choice D. So that's going to be your correct answer here. Next, 22. We have if x squared plus y squared equals 25, what's the value of d squared y, dx squared at the point 4, 3. This one here might take a bit of time, but it's going to be implicit differentiation. So we're going to take the implicit differentiation of x squared, which is going to be 2x, and then plus 2y, y prime, is equal to 0. Okay. Next, let's see how we're going to do this. I think I'm just going to solve for y prime here, and we're going to subtract 2x from both sides, so we're going to get 2y, y prime equals negative 2x. And then dividing both sides by 2, we'll cancel out these 2, so we get y prime equals negative x over y. Okay, so next thing we're going to do is take the second derivative of that, and we're going to be using, for this, the product rule. So the high is going to be x, or excuse me, negative x, and the d high equals negative 1. And the low is going to be equal to y, and the d low is equal to dy dx, so I have to put y prime. So we're going to have y double prime is going to be equal to low, which is y, d high, which is negative 1, minus high, negative x, d low, which is going to be y prime. Well, y prime is defined as negative x over y, right? And that's what this is going to be right here, over low squared, which is going to be y squared. And so if we take y double prime of substituting 4 for x and 3 for y, we're going to have negative 1 times y, which is 3, so we have negative 3, and we're going to have minus times a minus times a minus, so we're going to have minus x, which is 4, times this x over y, which is going to be 4 over 3, and we're going to have all this over 3 squared, which is 9. And so we're going to have negative 3, which is going to be negative 9 thirds, minus 16 thirds over 9, which is going to be equal to negative 25 over 3 divided by 9 over 1. And when we multiply by the reciprocal of 9 over 1, we're going to multiply by 1 over 9. So we get negative 25 27ths, which is going to be answer choice A. Now, if you just kind of think about what this is going to be, this equation here is going to be the equation of a circle with the center at the origin, okay? And at point 4, comma 3, we're going to have concave down in the first quadrant, so we know our answer is going to be negative for that second derivative, so either A or B. So we could use that if we need to or wanted to. Next, problem 23. Let h be a differential function h of 3 equals 2 and h prime of 3 equals negative 4. Let g be the function defined by g of x equals x squared times h of x, which is the following equation: a line tangent to the graph of g at the point where x equals 3. For this, we can do, as we've done several times in our exercise here, and set out a product rule organizer. And so h of 3 is equal to 2, and h prime of 3 equals negative 4. So that takes care of that h and h prime. And then we're going to have g, let's see, yeah, x squared. So we're going to have our other item factor is going to be x squared times 2x. So what we're going to have is that our point, okay, so for point, okay, we're going to have 3, we know that, and then if we plug in h of 3 is going to be equal to, well, we know h of, let's see, so we're going to have 3 squared for x squared times h of 3, which is 2, which is going to be 9 times 2, which is 18. So that's our y-coordinate. And for h prime of 3, we're going to have 2 times 2x, which is 3, plus negative 4 times 3 squared, which is going to be minus 9 times 36. So we have 2 times 6, so 12 minus 36, which is negative 24. So what we're going to have here is y minus 18 equals negative 24 times quantity x minus 3. It looks like it should be right. Our answer choice is D. Okay, our last of these problems is this one. If f of x equals tangent 2x, then f prime of pi over 6 equals, well, remember we have this tangent, secant, secant. So f prime of x is going to be equal to secant squared 2x times the derivative of the inside, which is 2. So I'm going to put that 2 out front. So f prime of pi over 6 is going to be equal to 2 times secant squared of 2 times pi over 6, which is going to be equal to 2 secant squared 2 pi over 6 is going to be pi over 3. Well, secant x equals the inverse of cosine x, which in this case, our cosine of pi over 3 is 1/2. And so we have, for this one, f prime of pi over 6 is equal to 2, and we have 1 over 1/2 squared, which is going to be 2 times 2 squared, which is going to be equal to 8. So our correct answer choice is E. So anyway, that's the 24 problems. This is a long video, and it's indeed much longer because I needed to explain as I went along, and those explanations took quite a bit more time than you're actually going to need on your AP test. But good luck on your test in May, and as always, thanks for viewing.